Today we are going to learn about addition and subtraction equations. So when we are working with addition and subtraction equations, we're going to use what's called inverse operations. We are going to use the inverse operation because they undo each other. For example, if our equation has an addition in it, we're going to use subtraction to solve. And vice versa. If we have subtraction, we're going to use addition to solve. So subtraction property of equality right here is when you solve an equation by subtracting the same number from each side. Addition property of equality is you add the same number to each side of the equation. The two equal sides remain equal. So here we have of equality, they remain equal. The huge part in this is going to be balance. We have to make sure each side of the equal sign in our equation stays balanced. So let's try number one. Number one says Ruben and Tara have 245 downloaded minutes of music. If Ruben has 132 minutes, how many belong to Tara? Write and solve an addition equation to determine how many minutes belong to Tara. So it already tells you addition equation, so we know we're going to be using addition. Okay, so words. Words are that we pull out the most important information. So here our most important information is that Ruben and Tara have 245 minutes of music. That's what they have together. Okay, we need to figure out Tara's minutes. That's our unknown. How many minutes belong to Tara? So our unknown is going to be represented by T. Our variable is going to be let T represent the number of minutes that belong to Tara. When we draw our bar diagram, our first diagram is going to show what our variable represents. Tara's minutes represented by T. Our second bar diagram is going to show that we have 132 minutes that belong to Ruben, and we have Tara's minutes that are T. And the total of the 132 of Ruben's and Tara's is going to total our 245.5 minutes. So we do have an error on this equation right here. So our equation could be what's represented by the bar diagram. Our equation is that if I add 132 minutes plus Tara's minutes of T, I am going to get 245.5. Okay, so let's look at that. 132 plus T equals 245. Okay, so what I have on one side is 132 and T. We're solving for T, so we want T to be by itself. In order to do that, I'm going to do the opposite operation of addition, which is subtraction. I'm going to subtract 132 from the left side of the equal sign, but what I do on the left, I have to do on the right to keep it balanced. Okay, I would change my equation if I didn't do it on both sides. So 132 minus 132, that's 0, so the only thing I have left over is this T right here, T. On the other side of the equal sign, I have 245 minus 132, and that equals 113.5. So we're saying that Tara's minutes of T is equal to 113.5. We can check this. We can fill in Tara's minutes. So we can say 132 plus 113.5. Does this equal 245.5? When we add those two together, yes, it equals 245. So our answer is correct. Check. Number 2 says that at age 25, Jeremy was the youngest person to travel into space. This is 52 years less than means to do what? To subtract the oldest person to travel in space, John Glenn. How old is John Glenn, the oldest person to travel in space? Write and solve a subtraction equation. It's saying subtraction equation. That means we're going to have subtraction in our equation. Okay, so let's pull out the most important information. That is that the oldest age minus the youngest is 52. Okay, so then our variable, what is our unknown? Our unknown is the oldest age. Okay, so we're going to let A represent the oldest age. And then when we draw our bar diagram, our first diagram, remember, is to show what our variable is. Our variable is age, and it's represented by an A. Okay, so then let's think about the second part of our bar diagram. Our total is our age. That's the biggest number, the oldest number. So that's saying that if I take 25 years, so let's write 25 years, and I combine it with our space of 52 years, that I get what I'm looking for, my age of the oldest person that traveled in space. So let's write an equation. What do I know? I know that the oldest age of A minus the youngest age, which is 25, equals 52. So let's solve this. So we have A minus 25 equals 52. It is subtraction, so we're going to have to do the opposite, which is addition. Remember, what we do on one side, we have to do on the other to keep the balance. So I have to add 25 and add 25. Okay, so A, I have A left over. I can't do anything with that yet. Negative 25 combined with a positive 25, that goes to 0. So I don't have to write anything under my line. I have an equal sign, and 52 plus 25 is 77. So that means that we're saying that A, John Glenn, is 77. Let's check. How do we check? We plug in our number that we just found for our variable. So instead of A, we have a 77 minus a 25. And once we subtract that, we see if we get 52. So over here, 77 minus 25. That's 2. That's 5. Yes, we get 52. So A equals 77. I would like you to read number 3 and try to come up with the words, variable, bar diagram, and equation. Once you feel you are confident in this one, then you may check your answer. You may press play, and then we will move on. So go ahead and press pause now. Okay, so you should have had that 150 meters plus lens meters is joules. Our variable, I picked M. For this, you could have picked X. That way you don't get our label of meters mixed up. But let M represent lens meters swam. So remember, our first bar diagram is going to represent our variable, len, comma, M. And then our bar diagram is saying that 150 meters, when combined with lens M meters, I'm going to get a total of 575 meters. So what is our equation? Our equation says that 150 plus M equals 575. So let's check if that's true. So you're going to keep your balance by doing the opposite operation to both sides. This is addition, so I subtract 150 from the left side of the equal sign, 150 from the right side of the equal sign. You take 150 minus 150, that goes to 0. I have m left on this side of the equal sign. 575 minus 150 is 425. I check by saying if I plug my variable back in and get 150 plus 425, does that equal 575? And yes, it does. Therefore, m equals 425. That's saying that Lynn swam 425 meters. Now I would like you to solve number 4 on your own, and we're going to go over this in class tomorrow. I want you to write the words, the variable, draw your bar diagram and equation. Once you find your equation, I want you to solve. I would like you to check your work and then tell me what that represents, that variable represents according to the problem. And you may answer your 2 summary questions on your own, and you can create a problem for your table to solve.